This
Information
conference
Technology,
will now be recorded.
organized by Electronics and Telecommunication Department, WCL Chandrapur area. Today we have Yogesh Sharma sir for taking expert lecture session. So we will start with the session. Yogesh sir, please.
Thank you, Shivangi. Hello, everyone. Shivangi, my voice is audible?
Yes, sir, your voice is audible and clear also. Please start.
Okay. Thank you for the feedback. Okay. So, hello, everyone, and good morning. And I think it's a third day, and it's a very interactive session so far for us, for all of us, and good session also. And I would like that this session will also be like that only. So today we will be starting our discussion. This TCP/IP internals and the protocols in different layers. Okay, so till now, what we have done. One second. Yes. So till now, in my previous lecture, when I was discussing about this ISO layer and TCP/IP models, so there I have discussed about protocols, layering, and all that stuff. So today we will be discussing more detail about all those protocols, because protocols are layer specific first of all, and they all interact with each other. So how they interact with each other, and that all thing we are going to see in our next lecture also, after this one, with some socket and socket paradigm. But now I will be more focused on the protocols and different layers, and I will be just briefly discussing about all those protocols so that you have a small idea what protocols are there at the different layers and how they work. So this our today's learning outcome would be knowing all these protocols, application protocols, transport layer protocols, and internet layer protocols. At internet layer, IP addressing and all the stuff had already been covered. So I will be just discussing a brief about all those protocols in that layer. Okay. So and as I've already told that we have already covered this protocol stuff, and each layer which each layer adds header information to the block of data passed to it from the previous layer. From the previous layer, instead I'm saying is the layer above it. So whatever data are there in layer 5, that would be having a header attached to it in layer 4, and that header plus layer 4 data, when we'll go to layer 3, is that layer 3 header will be attached to it. So that thing sorry, we have already covered. So in this presentation, we will look in detail at header information constructed at transport and internal layers. So those headers I will be discussing, because those are the integral part of our protocols, and it will always be used for every kind of communication you use for internet or for telecommunication or anything. You would be using those headers for communication over the network. Okay. So these are all the study material you can use to read more about all these things. So this you can have in slides. So first, basically what I have said is in TCP/IP model we have basically 4 layers. The physical layer is the mandatory one, so that is there, but the protocols which we are going to discuss in these slides are of these 4 layers only. And first one is application layer, in which we have got this SMTP, FTP, Telnet, HTTP, IMAP, POP. These are all different protocols for different use cases for different applications, and I have distinguished them on the basis of which one is using TCP and which one is using UDP. Means this, This RTP will be using, for example, RTP, the packet, the voice packets which we are transferring over the internet might be using UDP, and those IMAP and FTP on Telnet or HTTP, they are all might be using TCP, but they are all using IP header at the layer, internet layer, and then below at network interface we have got Ethernet or token ring or FDDI or ATM. So these protocols, I think they are also covered in previous lectures. This is more of that stuff, how they are interacting, means they are all interacting with each other. uh, these all protocols are sending data to the lower layer, and lower data they will be sending data to the upper layer. So it all depends whether it is a sender or a receiver. The receiver will be sending the data from layer below to the layer above, and the sender will be sending the data from layer above to the layer below, like this. Okay, now first we will be starting our application layers. So what application layer do? It handles high level protocol issues of representation, encoding, and dialog control. So actually you can consider this application layer in TCP/IP model as an accumulation of application, presentation, and session layer of OSI model. So it is responsible for node-to-node communication and controls user interface specifications. Okay, so this TCP/IP combines all application related issues into one layer and assures this data is properly packaged to the next layer. So this is our main motive of application layer. Uh, See here, these are the protocols which we are using. These are the examples, and I will be discussing more on this next slides. So these are the different protocols, and those protocols have different format of data, data structure, or encoding. They all are having different of thing that encoding stuff, and it will also do the dialog control and session management. So all these things are done at the application layer itself. So, for example, I will be taking the same example again. If you are using a, Skype chat or a Gmail, so when you log into a Gmail, then session will be established. So if you open a particular page, you won't have to log in again because the session is already been established. So that all things has been and the session has been established, and the protocol has been established that which protocol will be used to get the data, get the emails. So all those things are handled by a single application like our Gmail app. So the same thing has been done at the application layer itself, because all those application layer is interacting with the user directly. You are directly interacting with the application. So all those things which you are seeing, the format, the data, and the place where they are located on the application, all those thing has been done and properly managed at the application itself. So application itself is not application layer. Application is the thing which uses all these protocols and then get the data and then display in the pre in the location which it is desired to locate. Okay, so here we will just start with our HTTP protocol, the most common protocol. So HTTP is the foundation of data communication for World Wide Web, where hypertext documents include hyperlinks for other resources that the user can easily access, for example, by a mouse click or tapping a screen on a web browser. Okay, so it was developed. Development of HTTP was initiated by Tim Berners-Lee at CERN in 1989. So this is a brief history. So HTTP, how it functions? HTTP functions as a request response protocol in the client-server computer model. A web browser, for example, may be client and the application HTTP function, and the application running on a computer hosting a website may be a server. So the client submit the HTTP request message to the server, and the server, which provides resources such as HTML files and other content or perform other functions on behalf of client, returns the response message to the client. The response contains completion status information about the request and may also contain request content in the message body. And you have to note down that the port which we are using is port 80. Okay, so the role of these ports you will be needing in our and this port is distinguishing the HTTP client or HTTP application to which this data has to be transported. For example, HTTP request can be sent from a Chrome browser and they can be a request from our different what you call Gmail browser is there, and different applications are there. So how to distinguish between these different applications? So you are distinguishing them based upon the ports on which they are working. Like we have a Skype, one request is there, and when we have one request from our web server on the running on the Chrome browser. So both our applications are sending a HTTP request, but to whom to send this response back, it all depends upon the port which they both are using. On those port distinguishes both applications. Okay, one more important protocol is our FTP. This is called File Transfer Protocol. So it allows people anywhere on the internet to log in and download whatever files they have placed on the FTP server or upload it also. So it's a standard network protocol for transfer of computer files. So FTP users may authenticate themselves with a clear text sign-in protocol. So there is an authentication facility also, but normally in the form of username and password only. Okay. For secure transmission that protects the username and password, we have to encrypt it. So for that encryption, we are using SFTP, Secure File Transfer Protocol. Okay, or we can use SSH File Transfer Protocol. Sorry, it is not secure; it is SSH File Transfer Protocol. Okay, so it basically can run in two modes: one active mode and one passive mode. In active mode, clients start listening of incoming data connections from the server on port M, for example. Then it sends the FTP command port M to inform the server on which port it is listening. So now then server initiates the data channel to the client from its port, for example 20 port, and the FTP server data, which is a FTP server data port. Okay, but but in the situation when the this client is behind the firewall and unable to accept incoming TCP connections, passive mode will be used. So in this mode, the client uses the control connection and send the passive command to the server and then receive a server IP address and server port number from the server, which the client then uses to open a data connection from an arbitrary client port to the server IP address and server port number received. Okay, and here these are all well-known ports. So for this FTP, we are using 20 and 21 for server and client respectively. Okay. Now we have our DNS protocol. So this DNS it is a domain name system protocol. This is a hugely used protocol. So you might be knowing that when you're typing google.com, so it's not just by typing the google.com and you are directly accessing the google.com. There must be some mechanism to convert that google.com name, that is a domain name, into a particular IP address. So to do that, we have this particular protocol, and it has a well-defined protocol, port number 53. So it's basically a hierarchical and decentralized naming system for computers, services, or other resources connected to the internet or a private network. It associates various information with domain names assigned to each of the participating entities. Most prominently, it translates more readily memorized domain names to the numerical IP address. Okay, so it's you can it's there would be an analogy of it, very common analogy. It's a phone book. So in phone book, if you want if you want to call a particular person, so you might not be knowing its phone number. So but To know the phone number, you just open the directory, you just search him by his name, and there you will find the phone number of it. So the same thing is done for the domain names over the internet. You don't know the IP address of those names like google.com. You don't know the IP address, but those all searching is done at the backend using this DNS protocol. But there is an difference in there is an important and ubiquitous function of DNS, and it is central role in distributed internet services such as cloud services or content delivery networks. So when a user accesses a distributed internet service using a URL, the domain name of the URL is translated to the IP address of the server that is proximal to the user. Means it is just behind the behind the user. User don't know that this is happening. But the key functionality of DNS is exploited that different user can simultaneously receive different translations of the same domain name. A key point of diverges from a traditional phone book view of DNS. This process of using the DNS to assign proximal servers to users is key to providing faster and more reliable response on the internet, and is widely used by major internet services. Like we have got for example, you're typing amazon.com. So amazon.com, I'm just taking an example. So if you're typing in amazon.com, so this DNS will know that this server might not be in India. It is the server. This address is present somewhere in USA. That server is present in USA, and there this website is stored. So that .com domain has filtered out that okay, this particular website is to be searched and USA servers. And similarly for India. Similarly, for India, if you are typing amazon.in, so we will know that the website is present in Indian server. So this is the key differentiation using DNS. Okay, I'm not going much deeper into the DNS because it will take much time. We have a very limited time. And one more, I will just quickly go to Telnet. Telnet is a remote login thing where you all the Windows laptop you might have seen, you were able to do Telnet. Okay, so but in Telnet there are three major drawbacks: that there is no data encryption, there is no authorization, or there are several vulnerabilities which were occurred in the in the Telnet daemon. So these security related shortcomings have seen the usage of Telnet protocol drop rapidly, and especially on the public internet, in favor of secure shell protocol. So now instead of Telnet, we are using secure shell protocol SSH, and which was first released in 1995. So it practically has replaced Telnet altogether. Okay. Now we have got these all three protocols are used for our sending or receiving the emails, and they have specific ports 110, 143, and 25. They have these are all application protocols for our email services. So this thing you can read in the slide itself, but now I will directly jump to transport layer protocols. So this is a very important protocol, and it is being used by all these applications above. Okay, so those transport layer protocol and internet layer protocol, all these are being used by all the protocols above. So they are very important and they are huge topics, but I will try to cover it as much as I can. So it is analogous to transport layer of the OSI model. So it is responsible for end-to-end communication and error-free delivery. This is important thing. These are the only things which it does. It guarantees that it tries that the data which it has received from, I think for example, it has received from a Skype, it should be going to Skype itself, or it guarantees that there would be an end-to-end delivery. the from which application it has received the data, to that application only it has to send that data, and the data should be error free as much as possible. Okay, so it shields upper layer applications from complexities of the data. Means whenever you are writing something, you are not writing that which IP address to send, which port to send, which application to send. You are not doing that. You are just writing your data and expecting that it should be, when you are writing a chat application, then you are expecting that it would be delivered to the same chat application at the receiver end. Okay, so after much research and development on this particular layer, we are stuck with these two important protocols, UDP and TCP, user datagram protocol and transmission control protocol. These are the only two major protocols in this layer which we will be using. Okay, so first we will discuss a fairly simple protocol, a UDP protocol. So UDP protocol is unreliable and connectionless protocol. Connectionless in the sense it is not checking whether the end user is available or not. If you have asked them to send this particular data, it will send it, and it won't guarantee that it won't check whether it has been received or not. That data has been received or not. It doesn't do that. It just send the data. It just throw the data. So it was basically designed by David P. Reed in 1980, and you can formally read about it in RFC 768. Okay, uh, but it basically used for our real-time services. Real-time services, for example, like what we are doing now. We are doing in real time. I'm in real time sending a voice packets, and whatever I'm saying is converted to voice packet and are sent over the wire. Okay, or over the air medium. But you have to take consider it that this should be very fast. And at the moment when I have said anything, yes, it has to be reached to you also. So this thing is very fast. So UDP is very fast. So it's a benefit of not checking the reliability or the connection, because that connection is already established. See, you all are connected to this particular application, so that all thing might have been done on TCP protocol, that we will discuss in further slides. So that might have been done in TCP protocol, but this UDP is not now guaranteeing that okay, the connection is established or the user is receiving or not. It is not doing that. It is just checking that, and only one error mechanism is there, that is checksum. In UDP, it will just checking whether the data is correct or not, data or header is correct or not, nothing else. It will just send over the wire. Okay, so we have many real-time services like computer gaming and video communication, live conferences like this. So these all we will be using our UDP. And one more important thing is, if it is not delivered, so if to get the high performance, UDP also permits that packets to be dropped instead of processing delayed packets. Okay, so it does not process the delayed packets, it just drops them if the packet has delayed or it has come out of order. Okay, so this is a basic header of UDP datagram header. So we have got only four things in this particular header. We have got a 2-byte source port, 2-byte destination port, 2-byte length field, and 2-byte checksum. That's it, nothing else. And this source port and destination port, as I have already mentioned, this will describe to which application it has to send. This length will describe the total length of UDP header and UDP data. And checksum is a 2-byte thing. We will be discussing more about it. Okay. And one important thing is that there is a theoretical limit of the length. It's 65535 bytes. But in this 65535 bytes, we have got 8 byte this 8-byte header length and 65527 bytes of data. But that data part means the maximum data which we can send over the UDP header is 65527. but that also will be limited because we have got IPv4 header also, that is starting with 20 bytes. So the overall maximum length which we can send is maximum length of data which we can send is 65507. So this 65507 bytes of data which we can send over the this UDP header, but there are certain limits which we will be discussing further, that is MSS and all. So that will be limiting uh, the size of data which we can send over the network. So this is our UDP data protocol checksum. So in this checksum, sometimes we are using pseudo header also, so to check whether our data is correct or not. So it will only guarantee that data is correct, the checksum. It won't guarantee that it has been received at the other end or not. Nothing like that. It will just check that data is correct or not at the receiver end. Okay. So this is our header along with our pseudo header, UDP header along with pseudo header. Okay. Uh, so the one important thing is that when UDP runs over IPv4, the checksum is computed using pseudo header and contains some of the same information from the real IPv4 header. So the pseudo header is not the real IPv4 header used to send the IP packet. It is used only for the checksum calculation, as I mentioned. Okay. This is it in the UDP protocol, and now we are going to check the one of the important protocols which every application must use to serve particular application, so serve particular thing. Okay, this is our TCP. So going forward, I just want to clear you, make a ground for you to know about TCP. So, for example, if you are on a call, you are when you will know that the front person is available or not. When you say hello, and the front person is also saying hello, then you know that your connection is established, and the front person is also saying hello to you. So same thing is done by our TCP protocol. So first I will just give you briefly the what all TCP can do, and then we will discuss the TCP header. Okay. So this TCP in TCP, basically we have got synchronous flag and acknowledge flags. These are important uh, flags present in the TCP. So these are sequence numbers and acknowledgement numbers. So uh, what is there in it is that whenever we have to send the data, first we have to check that the front person is able to respond me or not. So what I'm doing is I am sending a synchronous packet to the receiver, and the receiver will acknowledge it that okay, I have received it, and then the sender will, when after receiving the acknowledgement packet, it will respond back, okay, I have also received your acknowledgement. So this is called three-way handshake. So once three-way handshake is completed, then you know that the connection is established. So TCP is a connection oriented protocol. Okay, we are not it's a logical thing, means logically we are establishing a connection, but connection establishment is all depending upon our lower layers, because you know in lower layers we have different hops, different routers, bridges, and different switches connected. So all those the real world connections are there on those uh, this internet entities, but this TCP is a logical connection established between the source and destination. And it is very important, source and destination. Destination is the one where it has to read the data, and the source is the place where the data has been originated. So this is between source and destination. This protocol works between source and destination only, not in between, because see what we have got in between entities are called switches. Switches will work only between layer two layers, not above it. And we have got routers. So routers will be working at the IP layer only. not above it. Okay, router might work at the layer 2 also, but they won't work above it. So this TCP will be working end to end, and it will be between our source and destination only. So this is the important thing. One more thing is we have got sequence numbers which are given to the segments so as to reassemble at the receiver side. Okay, if they arrive in different order, if they arrive in different order, they can reassemble the receiver can reassemble those packets based upon this sequence number. The sequence number of a segment is the byte number of the first byte that is being sent. Okay, and similarly we have acknowledgement number, which is required since TCP provides full duplex service. So acknowledgement number is the next byte that the receiver expects to receive, which also provides acknowledgement to receiving the previous bytes. Okay, so these are all different flags present. I will be discussing more, but these are different flags present in our TCP to give more details about the type of data which has been sent. Like if there is an urgent flag is present, then it is these are all flags used by our receiver. So receiver might be knowing that, okay, if I have got a urgent flag, this I have to process it urgently and I have to send it directly to the application layer. Okay, it won't wait for other data packets to be arriving. When it sees this packet is urgent, it will directly process it, and it will remove its header and send it to application layer above it. Okay, like if we have acknowledgement flag, this will tell that, okay, this is acknowledgement of my previous data which I have sent. And then we have reset and sync and fin function. This will terminate the session. Okay, then when we have a syn function synchronize, it will tell that it is creating a new setup, and the syn flag will be set up. So all these flags are present in our TCP header, which I will be discussing in next slides. So I'm just creating a this ground for you so that you know where they're all used. Okay, so as I previously mentioned that we can send at max 65527 bytes of data, but that is the theoretical limit. But there are certain limitations to it, and we are not able to send more than that. Those limitations are caused by this maximum segment size. So it's the largest amount of data which is specified in bytes that TCP is willing to receive in a single segment. Okay, for best performance, the MSS should be set small enough to avoid IP fragmentation. This IP fragmentation, I think this is also important thing. IP fragmentation is fragmenting the data part into different IP datagrams, and they are all sent over the internet because our internet resources or the resource available are limited, and from there when we are sending the data, they are all not in a big chunk of data. Uh, they are broke down into smaller chunks and then sent over the internet as a IP packets. Okay, so all this maximum segment size, or it all depends upon that particular thing. This our to avoid fragmentation also, and to if the receiving party is able to process those packet or not. So all those things are limiting factor to our data size. Okay, to accomplish this, typically MSS is announced by each site using the MSS option when the TCP connection is established, in which case it is derived from the maximum transmission unit size of data link layer of the networks to which the sender and receiver are directly attached. Furthermore, TCP senders can use path MTU discovery to infer the minimum MTU along the network path between the sender and receiver, and use this to dynamically adjust the MSS to avoid IP fragmentation within the network. So this is, and one more, this is called MSS, and then we have got a window size. You might be heard about this. Actually this window is the window at which our packet can be sent directly without having the acknowledgement received for those particular data packets. So this is a window of our data, the data window to which we can send the packets to the receiver, and that after that we are expecting that until this window we will be getting our response back. So we will be discussing much detail about it in next slides. So this is our client and server. I am just giving a graphical representation how three-way handshake is done. So this X is our synchronization number. So once X is received by the receiver, that is here it is server. So see it closely that once the synchronization number has been sent as X, but the server will be responding back synchronization number Y. It is his own synchronization number. But along with that, it is also sending the acknowledgement number X plus 1. This will tell, okay, now the next synchronization number or the byte it is expecting is X plus 1. Okay, so when the client will receive that, okay, X plus 1 is the acknowledgement number, means it has to send now, means the X has already been received. This is the indication is given to client. This is what acknowledgement is. Okay, and then it will sending the acknowledgement back to server with Y plus 1. So Y plus 1 is indicating that, okay, next byte it is expecting from the server is Y plus 1 because it has already received byte. Okay, this is a three-way general overview of three-way handshake. This is all okay. So here this in this we have got once the connection is established, data can be sent. So this is the three-way handshake. So once three-way handshake is done, then we can send the data, and each data segment includes a sequence number identifying the first byte in the segment, and each segment includes a request number indicating what data has been received. So this is what we have seen in a previous diagram. But one more thing is that there in real world scenarios, there might be a case that we have the packet, the next packet which the sender has sent, it has been dropped. So when it is dropped, so how the sender will know that it has not, the receiver has not received it, or that it has been dropped. So one of the ways is that the receiver, if not getting the data, it will fast is to transmit 3x with our X with saying that I need this particular data, means X plus 1. If it means for example, first the sender has sent the packet X, and it has been received by our receiver, so it will send the X plus 1. But the next packet, when it will send X plus 1, and it has not received by that particular receiver, then it will again send three times in a quick succession. The X plus 1 is sent to the sender again. So the sender will know, okay, the receiver is not getting the X plus 1 data which is it has previously sent, then it will retransmit that particular data again to the receiver. Okay, so this is the one of the ways to know that packet has been lost. So this is a this is an example of our duplicate X which is sent by the receiver. So that because it has not received this particular 2048 byte, so it has sent the X for 2048 byte in quick succession, and so that sender will know, okay, the receiver is not getting the 204 byte, I have to resend it. So this is just an example. One more important concept in TCP is buffering. Okay, so when we are discussing Windows, we are not most often referring to the TCP receive window. Simply put, a TCP receive window is a buffer on each side of the TCP connection that temporarily holds incoming data. Okay, the data in this buffer is sent to the application, clearing more room for the incoming data. In this buffer, if this buffer fills up, the receiver of the data will alert the sender that no more data can be received until buffer is clear. There are several more details involved that is basic. That is a basic function. So a device advertises the current size of its TCP window in the TCP header information itself. Okay, and this is also part of our TCP header size in our TCP header. Okay, so this is all explaining what I have already said. both client and server announces their with every ACK how much buffer space remains. So in those ACK also are having a TCP header. So in that it will be, for example, when a connection is getting established, so first this sender might not be knowing what is the window size, means how much data the receiver can process. So first, when it is sending the signal bit, it might send the window size as 0, but the after receiving it, the receiver might send this window size to the sender that okay, I may process this particular size of packets or size of data. So after receiving this ACK, this sender will now know that how much data this receiver can process, and it will uh, create those data segments based upon the size of window. Okay, same as send buffers. Now we have one more important concept, as we have already discussed, this ACKs. ACKs are also very important. So a receiver doesn't have to ACK every segment. That is, it can ACK many segments with a single ACK segment only. As I mentioned, that it has to, based upon the window size or the predefined number of bytes, it can send the ACK after predefined bytes or predefined window size. So this will greatly reduce the amount of X which is exchanged over the internet, and it will reduce the congestion over the internet also. So, and each ACK can also contain outgoing data, as I have already mentioned that along to minimize or to optimize this particular thing, we are not just doing handshaking. We are also along with handshaking, we are also sending the data. So while sending data, we are piggybacking this X. Piggybacking is these are piggybacked over the data and are sent over the internet, and those when we are sending the data, we are also handshaking it. Okay, we are doing both the things. And if the sender doesn't get an ACK after some time limit, it resends the data, which is already discussed. And one more thing is that this segment might be received in any order. They can be any order of reception of these segments. So these all thing is, as I already mentioned, these all are things are taken care by sequence numbers. So once the missing segments arrive, a single ACK can be sent for the whole thing. Means if we are sending a 5 bytes of packet, for example, and 5 bytes of packet we are sending, and only 2 byte the receiver has received first byte, second byte, and fourth byte and fifth byte. But it have not sent the ACK for our third byte, because third byte it has not received. So so it will be sending again that it has not received the third byte, and it will send ACK with requesting of third byte. Okay, and now when the sender knows get this ACK packet of third byte, that it has not, the receiver has not received the third byte, then it will resend that particular third byte again to the receiver through this ACK byte only. Okay, and after this after all the data has been transferred, or all the connection has been established and data has been transferred, then we have to have the disconnection of the session also. So this can be done at this layer only. So we can have different headers for that also in our TCP header. They are called reset header or fin header. So fin header is a gradual disconnection, that both parties are now over. Both parties have shared the data whatever they want to share, and now any party can disconnect it. So whether sender or a receiver, both can disconnect by sending this fin header in the TCP header. So, and this is a general flow. Like application 1 can send the fin of a particular X, that okay, now it has to terminate this session. So application Z will send, okay, now you can terminate. I'm not expecting. I've see here ACK is sent with X+1, means it is expecting X+1 data, but it is not used because the fin header is there. So once fin header is there, anyways it is sending ACK for X+1 packet, but it will terminate the session. Okay. and then it will send fin y. Okay, after receiving it, the terminate session, then application 2 will also send, okay, now I don't have to send data to you also, and I will also terminate the session. Then act for y plus 1 is received. Okay, y plus 1 received means it will just send that, okay, this termination message which I have sent for this synchronization number, it has been received by application 1. That's it, nothing else. The termination will be deleted, the session will be deleted. Okay, so this is a basic scenario of termination which I have just described. One more important thing is, see, in our TCP connection there are a whole lot of things are happening, like via three-way handshaking is done and all the data is being checked, the error correction is done, all these things are done, but these all take time. So due to the way TCP works, connection cannot be closed immediately. As I mentioned previously, that connection will be closed after fin or reset message, but they're not closed immediately. So packet may arrive out of order or be transmitted after the connection has been closed. So we have got few things: close wait and our what we call time wait. Those two things we have got. So in close wait, which is indicates that the remote endpoint, that is other side of the connection, has closed the connection, and time wait indicates that local endpoint side, that is our side, has closed the connection. So the connection is being kept around so that any delayed packet can be matched to the connection and handled appropriately, and the connection will be removed when they time out, when there is timeout, or there are certain limits which have been set between the both the application, that after this timeout I will close the connection. So you might have already seen that if you are signing out or you're terminating a connection, it just take a bit a second more to terminate the connection. This is because it is getting information if any more packet is arriving or not, or it is just getting more time. It is just taking more time, so that if any delayed packet is arriving, it should be delivered, and after that it will be closing that connection. Okay. So these are the questions you can ask for yourself. If you know these answers, then I think you might be knowing all those stuff which I have described to you. Okay. So, certain features are there which I've already covered, and as it is mentioned here that it is connection oriented, and it receives the byte streams, means from the upper layer. From sender's perspective, it receives the byte stream, and from receiver's perspective, it delivers the byte stream to the application process. Okay, and we have a reliable data transfer due to this three-way handshake, and flow control. Which keeps sender from overrunning the receiver. So this flow control, how it is taking this flow control, this due to that window size. Okay, and we have a congestion control which keeps sender from overrunning the network. That is our what we call MTU, maximum transmission unit, that is taken care in congestion control. So all those things which we have discussed are all have the these are the properties of our TCP. These are the features of the TCP which are there. Okay, so here in this diagram also we can see that TCP is receiving those bytes, and this is the segment has been shared at the layer specific stuff. Means TCP at the transport layer only this segment will be transported. Okay, so this is a general TCP segment header, TCP header. Okay, so we have got as we have already mentioned, source port and destination port is also there in it, as I was in UDP header, but we have got much more information in this header than the UDP header. First, I have mentioned about sequence number, I have told about acknowledgement number, but there are other fields too. Means we have got data offset, what is the reserved bits, what are these flags, different flags I've already mentioned, some of the flags I've already mentioned. This is the window size which I was discussing, and checksum is there to check whether the data is correct or not. Urgent pointer is there. So I will just briefly describe about this whole thing. This data offset is, I think here is a 4 bit. So it's a size of a TCP header. When then we have 3 bits reserved bits are there. they're all set zeros, and they are for future purposes. And we have got 9-bit flags. Every bit has certain meaning in it. So this I have mentioned in the slides. You can read them. So, and most of them I have already discussed. Okay, then we have got the 16-bit window size. The it's a receive window. The number of bytes that the sender of the this segment is willing to receive. Okay, the key feature. It is a key feature of our TCP flow control. And then we have a 16-bit checksum. It's for error checking. It's a bit same with the our UDP checksum only. It's here also we are adding all the bytes, all the bits of the our UDP header and making it one's complement. This is the general procedure of checking the checksum, and at the receiver end we are just checking the checksum whether it is correct or not. If the checksum is correct, then the data which it has received is the one which has been sent by the sender. So this checksum will be used to check the integrity of the data. Okay. Then we have this options field also. So it's a variable field. Uh, uh, one example of option is the maximum segment size. By setting this option, the sender advertises the maximum size of the segment that it can process. The receiver must honor this value when sending the segments. Okay, so this is the option field which the sender might send. Okay, and then we have padding bits also, which are all set to zeros. So this padding bit ensures that the TCP header ends and data begins on a 32-bit boundary. As you can see, we have a 32-bit boundary over here. Okay, and then we have a usual data. So this is a basic TCP segment. All this stuff is described over here. These are all things I have covered. TCP segment fields are there. Every field has a different values which can be used by the receiver to process the data accordingly. Whether it is an urgent acknowledgement, it's push data, it's a reset data, synchronization data, it's a fin data. All this I have already discussed. Okay. One more important concept is that TCP congestion window. Okay. So, what is TCP congestion window? It actually it's kind of our window size only. So it in heavily loaded pure datagram networks with end-to-end retransmissions are there. As switched nodes become congested, the round trip time, though through the net increases, and the count of datagrams in transit within the net also increases. I'm reading what I'm reading is I'm reading the exact phrases which are written in our this RFC. So in RFC, this congestion for this congestion, they have given a reason of it. So I'm just reading that. You have to read it carefully. That as this is a normal behavior under load, as long as there is only one copy of each datagram in transit, congestion is under control. Once retransmission of datagrams not yet delivered begins, there is a potential for serious trouble. So this is exact words I have explained to you. So for example, here if we have got a receiver window which says to sender that it can transmit 8K size of data, but the congestion window is only 4K. So then sender may
हो गया लगता है
may only send the 4K. So this congestion window and the whatever the sending and transmit, whatever the minimum value is there, it will transmit that only. For example, if the congestion window is 8K
Yogesh
but
sir.
the receiver can only send 4K, then the sender may only transmit
Hello,
4K.
Yogesh sir.
So whatever the minimum value is there between the congestion window and the sender will send the minimum size of the of the two. Okay. And this is general
Hello, Yogesh
window
sir.
was, as you can got a license by act at the starting point, and so send all packets without receiving the act of the receiver or timeout timer for the packet it received. In receiving the act from the receiving device, the sending device slides the window to the right side. So it is sliding the window to only that portion of window to the right side, like the act of it, pocket for which that left boundary to the right side. So in this case, sending from the receiving device, the sending device can slide its window. Sending device can transmit 6 also. Means now it has one more. If it has acknowledgement of segment 1, then it can now send a segment 6 also. Okay, so the size is 5, but at the time it can send 5, but the it's a sliding window protocol, so window will slide. Yes. Hello.
Hello.
Yes, Shivangi. Yes.
Sir, actually there is little problem over your side in the connection, so you're not
Hello.
audible clearly. Hello, you're not audible, sir. Clearly you're not audible.
Oh, 1 second. 1 second. Hello. Am I audible now?
Yeah, sir, you're audible now.
Okay.
Okay.
I'm connected via mobile now, so that is causing a problem sometimes.
Okay, but sir, you're clear now. You can please continue.
Okay. Okay. So, so this is the way sliding window protocol works. Means the window will only slide if it has received the acknowledgement of that particular data segment. Okay. So now we will jump to the internet layer. So what is the purpose of internet layer? So internet layer is responsible for our logical transmission of data packets over the internet. So now you have seen that we are going down from application layer to now we are in internet layer. So at the application layer, we have created the data and we have formatted the data. At the transport layer, we have identified to which port the data has to send or to which application the data have to send, and all the stuffs which are present, all the error checking and all data error checking is done at the uh, transport layer. But in this layer, from this layer, the internet layer, the actual uh, what you call, to which sender it has to send the data, and what is the IP address of data, all this stuff will be handled at that internet layer only. Okay, so it's basically a logical transmission of data packets over the internet. From this particular layer it starts. So it can be compared to the network layer of OSI model, and and there are four basic main points of our internet layer. First, it transmits data packets to the link layer. It routes each of the data packets independently from the source to the destination using optimal routing. It reassembles out of order packets when they reach the destination, and it handles the error in transmission of data packets and fragmentation. Uh, sorry. Uh, so it handles the error in transmission of data packets and fragmentation of data packets. Okay, so these are the basic 4 points of 4 features of our internet layer. Okay, so in this where it is located in our internet layer, and it's between our data link layer and transport layer. And basic protocols in this is our ICMP, ARP, and RAP that I will be discussing in my future slides. Uh, so this is our IP datagram. IP datagram is again datagram is created when we are adding a IP header to the our TCP IP data header. Okay, once it's a layer 3 header, so we are adding a layer 3 header to the layer 4 header. Okay, uh, it defines the packet format, the addressing scheme, and the IP, the IP itself. Uh, and the header includes the source IP address, destination IP address, payload size, which are the some of the stuff I will be explaining in future slides. What is the important thing is I want to explain is here is uh, we have got routers which are basically the intermediate nodes which are helpful for us to transmit the data between the networks. See, if we have this is a basic concept which I want to explain it here. Rest all is the theory thing, but this you have to keep in mind that if you have got a router, so router is basically used for communication between the network means they're all in different subnets. They're all different, and those subnetting all stuff I think they are all covered in yesterday's lecture. But when we have different subnets and we have a different networks altogether, then we will be using routers to do that. But if we are in the same network, okay, and so in that case, I think switch might also be useful. Only switches can only switch can also do the purpose for us to communicate to the sender. Okay, in that case, we might not be using the routers. So as one more thing is there that this is a connectionless communication is there. Means connectionless means that connection is not established between the sender and the receiver. They might be a different hops or different nodes which are connected to each other, and we have to send the data first to those nodes, and those nodes will be sending to the different nodes. For example, in when we have when we have to send the data from our for example Delhi to Bangalore. So from Delhi to Bangalore, there is no direct data transfer. First, from this Delhi to the local router, it will be transferred the data, and then from those local routers from to the internet service provider router will be transferred. Then from those internet service provider, it will be hop to different routes between the country, and then it will be received at the Bangalore's internet service providers hop, and from there it will be sent to the local routers and then to the destination. So there are many different hops in between, and those all are having different IP addresses. So this is all done. This is all called routing, in which data is routed from different nodes to the destination. Okay, and at each node at each intermediate node, it will check the destination address of the datagram and forward it to appropriate interface. So one example is this. uh, the same thing I have discussed is here. See, in more detail. See here, if this is our router 2. Okay, so router 2 is having a routing table is there. So we are using a routing table to, so every router in between is having a routing table to which it has to send. So if for example, if the destination is 30.0 is a 30.0.0.0.0 means in a 30 network sub network, so it will send directly to next hop 40.0 next hop. And if the destination is 40.0, it will directly directly transfer it to that particular network because it is directly connected to it. And if it has to send 128, then it can again send directly to that particular network because it is directly connected. But if it has to send 192.4.10 network, then it has to send it to first 128.1.0. Okay, so it knows in this is the routing table. So in routing table only it knows to which next destination it has to send the data to. Okay, so it is all I think it can be statically configured or dynamically configured. These are different ways those things are configured in the router. Okay, this all thing is already covered I think in previous lecture. It's just brief introduction that we have got internet and what is subnetting. This we have got in internet IP address. We have got one network address part also and one host ID part also. So all these things is I think already been covered in previous lectures. So this routers will do the best effort delivery. They will try their best effort and best path possible. That is shortest path possible. They use their best effort to deliver the packet to the destination. Okay. Although IP makes the best effort in datagram delivery, it does not guarantee proper handling of these particular things. That is datagram duplication, delayed out of delivery, or corruption of data, and datagram loss. So you are seeing in TCP header, we are guaranteeing that the packet will be delivered error free, and we are guaranteeing that okay, the packet will be delivered at the end. But in this IP protocol, they are not guaranteeing anything. So we are the TCP header is guaranteeing on the lower layer, which is not guaranteeing anything. You're getting point. So this is the beauty of our interconnection, that without having a, a confirmation or that the lower layer will deliver this packet or not, or the lower will packet in the particular order or not, the upper layer is handling all those stuff. Okay, so this layer is not guaranteeing anything. It is sending data out of order. It might send the data corruption. It might send the data in corrupted format, or there might be a data loss during the course of transport from one node to another. But then also the upper layer is handling all the stuff. Okay. Now we will see the IP header itself. So IP header actually it's got all these fields which I will be discussing in next slide. So it has got version number. Version number will tell what version of IP header we are having. Nowadays we are having version number 4 and 6. So version number 4 has around 4 billion IP addresses. But at the time of starting, those people who were developing internet and developing this IP header, they were knowing that 4 billion is too much for any network and too much of any host that can be connected. But as the number of people are increasing, as the number of connection are increasing, as the number of intermediate devices are increasing, now there might be a future in which each and every device is having a IP address, or it can have multiple IP addresses. If you have a virtual system installed in your system, you can have a single device can have a multiple IP addresses. Okay, and every device can have an IP address. In future, in 5G networks, we can have IP address for cars also, for cycle, for each and every equipment we might be having an IP address. So for that purpose, this number is very small. And to accommodate this, we have got IP version 6 headers. Okay, so IP version 6 had two raised about 128 addresses. So it's too much for anything we can consume in our future. As of now, we can think that it is too much for now. So that supports 2 raised to power 128 addresses. But today, to simplify the things, we were just seeing this IP header. So IP header had the different stuff. First we have got this version of IP address. It is IP version 4 or IP version 6. We have got header length, which is the length of header in 32-bit words. Okay, and we have a service type. It is information about the data transmission is prioritized or not. What priority of the service we are transferring. Okay, then we have total length. It is the length of datagram measured in octets and includes the header and data. And see, these are the important fields for fragmentation. This is the identification, this is the flags and the fragment offset. So as I previously mentioned that based upon the network speed and network capacity, we might have to still fragment the data in smaller parts. So that thing is taken care by these three fields. Identification flag means it will tell whether we have a fragmented data or not, and then we have got flags that this particular data is fragmented or not. And then fragment offset. This fragment offset is used to recombine the data at the receiver end. That after it has received all the data from this offset, and this is the last offset we have received, it will combine all the data and it will send to the upper layer of one single segment. Okay, so this actually there is a very big theory about it, but I will just tell you that these all three things are important for fragmenting the data. Okay, then we have a time to live bit, which is the 8-bit field. It is the maximum time the datagram is allowed to exist in the system, and each router that hands the datagram decrements the TTL by 1. Okay, so this will be helpful when in the cases when we have a loop inside the network and the packet is always going through that loop. So to avoid that, we have got this time to live uh, field, so that if the packet is in loop, that should be discarded. Okay, then we have got then we have got type field, which is a indicates which transport layer protocol the datagram is passed to. It is a UDP or TCP. Then we have got a 16-bit checksum is used to verify our header and data, and it is recomputed as
Shivangi,
Yes, sir. Hello, Yogesh, sir. Hello,
or
Yogesh,
if
sir.
there
Are
is
you
some
there?
problem,
Yeah. Okay, give me 2 minutes, sir. I'll connect to Yogesh, sir.
hello. Am I audible?
so now you are audible. Yogesh sir?
Hello,
Yes, sir.
hello.
Hello, Yogesh, sir. You're audible. Hello. Hello. Dear participants, kindly wait for a few seconds. There is some connection problem. Sir will reconnect again. So please stay connected. Okay, there is one announcement for the participants. Our feedback link will get active by 12. The feedback is comprehensive and will require time to fill it fully. We are hoping sincere feedback from participants as it will help in quality management in future programs. Further, kindly note that certificate shall be provided based on feedback and attendance. Participants, please keep your mic on mute. We will start our session shortly.
Shivani, am I audible?
So you are audible, but there is also some problem with your connection. It's not clear.
Not clear. Are Shivangi no?
Yes, sir, you are audible.
Okay, thank you.
Sir, if
So,
possible, please start with a few previous slides because you were not audible for quite some time.
so sorry for that. I was just discussing about this IP datagram header. So I will again start with that IP header only. Okay.
Okay, sir. Okay.
Sorry everyone for that glitch. There is a network error in my area. So as I was discussing different fields of IP datagram header. So where as I have already discussed about this IP datagram, why it is used. So first we have, as I mentioned, I think I will repeat myself why we have got these versions. We have got IPv4 versions and IPv6 versions. So IPv4 version is actually it's a 32-bit number, and we have got around 4 billion different IP addresses which we can assign. But at the time of starting this they were thinking that this 4 billion numbers might be more than enough for any network devices which would be in internet. But now we know that due to the advent of 4G and 5G technologies and the number of devices, the explosion of devices is there, the number of devices which are needing that IP addresses would be a huge, humongous IP addresses. That is why nowadays in IPv4 address paradigm, we are using private IP and public IP, and also we are subnetting it. So all this stuff we have done to maximize the IPv4 address space, but still it is not enough in coming future. So for that we are having IPv6 address space also, which is having 2 raised by 128 IP addresses which can be assigned to different hosts. Okay, so this version will be telling the what type of header it is there, then header length is there, which will tell it is a 32-bit header length of our header. And we have got a service type. It gives the information about how data transmission is prioritized. Okay, then we have a total length. It is of 16-bit. So it is a total length of datagram measured in octets and including header and the data part. Okay, and then we have got identification. It is a 16-bit header field, which its value assigned to an 8 assembly of fragments. Okay, so as I mentioned, this identification, flags, and fragment offset, these 3 fields might be used for fragmenting of the data and assembly of the data at the receiver end. As I also mentioned, that maximum transmission unit is limited, and to send the data or if the from the upper layer we have, for example, we have received a packet of 1000 bytes, but we can send only 100 bytes. We can send only 100 bytes. So so we can send only 100 bytes. So we have to fragment that 1000 byte data which we have received from TCP header to 100 byte each. In for example, 10 different fragments will be created, and those 10 fragments will be having a fragment offset, and at the receiver end those 10 fragments will be received and will be combined with the help of this identification fragment offset fields. Okay, and this time to live is very important field, which will be used when we have a packet which is going roundabout during the different hops in between. So to check whether the particular packet is going through the network and it is just going roundabout in different nodes, we have to place this time to live field, and at each hop this value will be decreased, so that if we have got time to live is 64 and we have got 10 hops in between, so it will be at the receiver end it might have received at 54, but if it is going roundabout, that 64 will be consumed in the path itself, because we might be knowing that it has been consumed in the path and it is not able to reach the destination, and that packet will be dropped, because that may cause congestion in the network, because this packet, when we are transferring over the over different nodes, this uh, hovering packets might cause the congestion. So after some time to live packet is expired, then those packets are discarded. Okay, then we have got then we have got a type field. Type field is a 8-bit field which indicates which transport layer protocol the datagram is passed to. If it is a UDP or a TCP, that we have to know while sending to the upper layer. The receiver must know. Then we have a checksum, and then we have a source IP address and destination IP address. Okay.
and then padding, the usual padding which we have already discussed in UDP. And every the padding is same for every UDP packet or TCP packet or our IP packet. Okay, so these are all explanations of it. Different headers. And this IP routing, which I have explained previously, that this is the way this routers will work. This router will route the packet through different routers or intermediary nodes in between before reaching to the destination. Okay, so this is the very important function of IP routers, and there are many criteria that could be used to make routing decisions. As we have previously discussed in our discussions, like there are network categories are there are network topology, network loads are there, different network loads, there are different datagram lengths. So based upon that routing is performed. Means if a router knows that there is a congestion in particular router and they can be apart from other router where there is less congestion, it will use that part for this particular data packet. Okay, so there are many ways, many reasons of choosing a particular path. Okay, so these are some of them. And this is a question one can ask. So host will do the routing decision? No, host won't be doing the routing decision. The routing decision is done by the routers, the intermediary routers to which to reach the destination. Okay, so routers will typically transfer packets from one network to another. The router has the responsibility of transferring the packets from our network to the different network or to the destination network. So both source and destination can be in different networks. It's the router that will do the routing. Okay, so this has caused us to have a direct routing, direct and indirect delivery. So direct delivery is when we have a source and destination IP addresses in the same network, then we can have a direct then we can have a direct delivery, because in that case we will not be going directly to the router, or router will directly know that okay, it is in the same network, it has not to send to the outer network. And indirect delivery is when the router has to send the data packet to outside the network. Okay, so this is all explanation. And IP also, this is also having IP routing table, which I have already explained. So this is the IP routing table of middle node R, in which if it has to send the data to the network 20, it will directly deliver to the 20, and because that network is directly connected to that router. Okay, but when it has to send to the network 10, it has to send first to 20, and then from 20 it will be redirected to network 10. Okay, so each router will have a routing table at the startup. It can be statically defined or it can be dynamically defined through the course of time, so that when the router is been installed or it has been installed, so network administrator might update the routing table manually, or it can be automatically done by the router by different technologies. Okay, I will just speed up the thing so that we have another session also. So we have got this routing table at machine M, which contains the pair N or R, which I have already explained. Okay, and this routing table size can also increase or decrease based upon the number of nodes it can send the data to or receive the data from. Okay. This I think this is the important protocol, layer 3 protocol. I will just briefly discuss about these protocols. This is the internet control message protocol. It is used for detecting the error in the network. For example, you might have all used the ping, whether you are able to ping the google.com or not. So that thing, that ping, that is an application layer protocol, is using internally this internet control message protocol to know whether the destination is reachable or not. So it's a supporting protocol. It is used by network devices, including routers, to send error messages and operational information indicating success or failure when communicating with another IP address. For example, an error is indicated when a requested service is not available or that a host or a router could not be reached. ICMP differs from transport protocol as such as TCP and UDP in that it is not typically used to exchange data between systems, nor is it regularly employed by end users network system applications. Okay. So internally, this it is having basically three parts. This protocol having three parts. What is this? Error report errors and internal, which 1 second. Yes, this is there. This protocol has basically three parts. One, what is the type of error, and this code will give more information about the error. There's sub information about that error, and this checksum to check that whether the information is correct or not. That the IPv4 it will contain the IPv4 data field also. Okay, this checksum. So this ICMP error message contains the data section that includes a copy of entire IPv4 header plus at least the first 8 bytes of the data from the IPv4 packet that caused the error message. The maximum length of error message is 576 bytes. This data is used by host to match the message to the appropriate process. If a higher level protocol uses the port number, they are assumed to be in the first 8 bytes of original datagram data. Okay, so you might be now knowing that what protocol ping is using. Okay, and two more things, then I will just wrap it up. One thing is how will you be knowing that if you know the IP address, how this low layers know what is the MAC address of the destination. Means you know anything needs to be reached to the particular destination. So destination has three parts: ports, which will distinguish an application, which application it has to send. Then we have got IP address, the location of that particular device, and then the MAC address, the exact device itself. Okay, so to know the MAC address, we have got this address resolution protocol in place. Okay, so it's a communication protocol used for discovering the link address, such as MAC address associated with the given IP address. This mapping is critical function in internal protocol suite. ARP is defined in 1982, and you can read about more details in RFC 826. Okay. So we know that at first, if you are not knowing the MAC address of it, so if, for example, if you don't know the sender don't know the MAC address of the receiver, then it will be sending all bits, this MAC bits as 1. Okay, so this at the layer 2 we have got the source MAC address and destination MAC address. So source MAC address we might be knowing, but destination MAC address we might not be knowing. So there we will be filling all ones. All ones will tell that this packet has to be broadcasted. Okay, and the same thing is done in ARP resolution. ARP resolution is done. I can just give you this is the example of ARP resolution, how it is done. It will ask everyone in the network that I need to contact this IP address. Please tell me the Ethernet address or MAC address of this particular IP address. So all those who are not having this IP address will say nothing to it, but the one who is having this particular IP address, it will respond back that I've got this MAC address and this is my MAC address. Now when the next packet will be sent, it will be filled with that particular IP address, and this value will be updated in this in its own entry. It will contain a cache of IP address and MAC address combination, and next time when the packet needs to be sent, it has to send to that particular MAC address. Then it will check that cache. Okay, that cache is also updated randomly. Okay, now we have got
Sir, Yogesh sir, 2
yes.
minutes. Actually, mistake. Your slides are not there. I'll make you presenter again.
Okay.
Give me 2 minutes. Mm. Okay, sir. I have makes me presenter, sir.
Okay, I'm sharing now. Okay, I'm just over with it. I'm just skipping just brief information. My screen is visible.
Yes, sir, it's visible now. Please start.
Oh, few more minutes, it will be over. Okay. And the reverse of it is RARP. Actually, RARP is a previous form of our when you are first connecting to the network. Now you might be knowing your MAC address, but you don't know your IP address. So for that purpose, RARP was used. Now it has been replaced by DHCP, Dynamic Host Control Protocol, which in which we have got a central server which will assigning you to the IP address. Okay, that will be dynamically configured and dynamically changed. So it was a previous form of RAF in which what we can do is we are just sending everyone that this is my MAC address, please can you tell me my IP address. Then who is a DHCP server, it will revert back your with your IP address and you will be updating your IP address. That's it. Okay, so this is all the summary of it. Thank you. If any questions you can ask.
Okay, thank you, Yogesh sir. We have few questions from the participants. Uh, we have this one question from Vikas. Why the port concept is there? Is it physically there or it's just an imaginary concept?
Yeah, actually, it's not an imaginary concept. Port is a logical concept. Okay, logically, you are distinguishing two different applications with the port number. Okay, port number is itself a distinction of to the kernel. Actually, it's all implemented at the kernel level. You are developing an application, but all those things are implemented at the kernel level. At the kernel, and which kernel will know that to which application this data have to send to. Okay, and to from which application it has received the data. Okay, so that port number will distinguish the application. So if we have a general port number 80, so kernel will already know that this port is for our web servers and this is for our this web client. Okay, so this is a logical concept only. And as our all these layers are logically concept, this TCP layer and IP layer all logically this until TCP everything is logical. And after TCP, internet and MAC layer, all is it all depends upon to which hop or to which destination it has to send the data. Okay, that is pure physical.
Okay, sir. I'll request participants if there is any question, please ask. I don't think so, sir. There is any question.
Okay.
Okay, thank you, sir, for this wonderful session.
Thank you, Shivangi. Actually, there was network connection error in my side. I will please pardon me for that. And
No, sir, it's
I will try to. Yeah, I will try to complete the next slide as soon as possible because that is a bit more complex and more actually kernel and system calls are there. So a participant might feel a bit bored, but I will try to cover as simple way as possible. Okay.
okay, sir. No problem, sir. We will share your slides with the participants.
Okay.
Thank you, sir. Okay, dear participants, here we will take 5-minute break and then we will start with our next session. So please stay connected. And our feedback link will start in 10 minutes. So please kindly fill the feedback form also.
इक्वल टू झालं म्हटलं आहे ते. ओके ठीक आहे ना, इकडे काही कन्फ्युजन नाही झालं ना.
Dear participants, please keep your mic on mute.
थांबा लागेल ना. बाहेर चाललो.
Okay, dear participants, we will start our next expert lecture session, which will be taken by Rohit Raj Mishra sir. Rohit sir is NIT Silchar pass out and earlier was working in Sony India. Currently, he is senior software engineer with Monte Vista. I request you, sir, to kindly start with the session. Sir, please. Rohit sir. Rohit sir, are you there?
Yeah. Can you see my screen?
Yeah,
Can you
sir.
hear
Your
me?
screen is
Okay.
visible and you are also audible. Please start with the session, sir.
Okay. So, hello all. Um, so today's session is basically on internet applications and networking. So I think in this whole course, you might have already covered all the layers in depth and um, and all the details like regarding physical layer and network layer and all. So what my idea of this session is that I would like to introduce you to the application side of the networking. So something that you can use in your daily life basically, and somewhere where you can start. So okay. Is my camera also on? I'm not sure actually. Shivangi?
No, sir, your video is not on, but your
Okay, okay,
presentation
okay.
is. Yeah.
Okay, okay, okay. Thank you, thank you. Yeah. Just give me a moment. Okay. So hi, I'm Rohit Raj Mishra. I'm currently working in Monta Vista as senior software engineer, and I have done my BTech from NIT Silchar in 2008 to 2012 batch. So basically, currently I'm working on the Linux embedded side. So I'm a user space developer. So basically, our task is to work on the embedded system operating system side. So there is hardware, then there is kernel, and then there is operating system and application. So basically, we work on operating system and above layers. So for today's agenda, so we will be talking about application layer and things related to that. So in the application layer, we will be talking about protocols. Then we will be looking into web applications. So there we will discuss about web protocols and application programming interface API, which is a very, I think, a popular term. And then we will do some hands-on session to create some small websites also. Then we will discuss about are they secure or not, like, and how the IPs, when you hit a website, how that IP is resolved, how that name of that website is resolved to an IP of the server. Then we will discuss password hashing mechanism for security. We will be also discussion HTTP and HTTPS, what is the difference. Then in the end part, that will be a very light session, I would like to introduce you some of the prototyping technologies that are generally used. So sometimes what happens that suppose you are a researcher and you have some idea, you are good into academics and all from the PhD side, or if you are totally new to like first year or second year, but you are not familiar with enough technologies to implement your idea. So we will be put some light on that side also, that some popular tool that you should know if you want to implement your idea and make a demo of it. And then we will be discussing out what is cloud, because cloud nowadays is a very popular term. So that is the agenda for today. So without any delay, we will start. Shivangi, is my voice clear or any issue
No,
is?
sir, your voice is
Okay,
clear.
okay, okay. Thank you. So in OSI layer model, you might have already seen OSI layer model. So basically, you might have by now already know about physical layer, data link layer, network, transport, and above this transport, I think the main crux of applications start, like session, presentation, and application. And by now you already know that the specific layer of one side talks to the specific layer of the other host. So like application talks to application, but the data flow goes like from layer 7 to 6.5, and then through the physical connection, it can be an Ethernet cable also, it can be Wi-Fi also. So through that data, and then again it is decoded back, and the application layer security and everything is like peeled off, the layered are peeled off, and then the data is received on the application side. So we will be talking about the application side of the things. So basically, understanding the application side, first thing is like what are protocols? So as the term suggests, as we already know, I guess, protocols are the set of rules basically. But why do we need it? So suppose if I develop an application and you develop an application, there may be some differences on the agreement, that how the syntax and semantics should be. So the first thing is the syntax and semantics. Then there are the like confusion may come, like who should initiate the interaction, like server or client. Then there some error may arise. Then what to do if an error arise, like 404 error, the very famous like page not found errors generally that you see. And then like who will terminate the communication, and many internal handshake related things and all. So basically you can develop a website or application as like a private protocols, like you and I agree on some set of rules and that we can do it. But if the internet grows rapidly and like there will be millions and billions of users, so there was a need of standardizing everything. So the protocols came into play. So protocols are nothing, just a standard community which makes a rule how a API should be written, how a web protocol should be, who should initiate and all. So those are basically called protocols. So today we will be discussing about web protocols. So in web protocols, I think there are three main things that we would like to discuss. One is HTML, one is URL, and one is HTTP. So HTML is basically the skeleton of a website. So the components with which the website will be made, like a heading, like a paragraph, like there will be divs, divisions, and there will be metadata. So all these skeleton are represented with HTML. Then there is URL. URL is nothing that you see in your browser address bar. That is the URL. And HTTP is basically, you have seen like HTTP colon slash slash google.com. So HTTP is the transfer protocol, hypertext transfer protocol. We will discuss about these three. Okay, so before that we start discussing about websites, we would like to clear some web development basics. Most of you, I think many of you might have know by now that there is like front end side, there is back end to a website, and how a front end talks to back end, that is somewhat done through what is called API, application programming interface. So API is basically the connecting part between a front end and back end. So basically what we see as UI and all is front end, like you have seen the Facebook login page and the look and feel of that. But most of the processing does not happen on the front end. So like front end is basically just processed by your browser and does not have that kind of capability to process data. Like suppose you have a machine learning website and it need to crunch uh, terabytes of data, then it does not happen on front end, that happened on back end. Back end returns the result to front end via API. And where are these things stored? Suppose you log in into a website, when you sign up to a website, where are these things stored? They are stored in a database basically, and backend handles that database connection also. So suppose in this diagram you have a website, say Facebook. Then the first thing comes the login and authentication. So that is it can be normal also, and nowadays there is standard for OAuth authentication it is called. So how that OAuth came into place, kind of interesting, because suppose you log into basic website, you does not need to provide say permission to other application. But in Facebook and other website, you nowadays might have seen that if you play a game through Facebook, and you can log in to other games and applications through your Facebook account. So Facebook account gives a standard set of permissions. Those set of permissions does not have full control over it. For example, they cannot submit a post on your behalf, they cannot message to one of your contacts. So these kind of restrictions are put by OAuth. It just gives enough permission to like read the metadata, like user information, like your location and your name, whatever you allow to share. So that is basically OAuth. So, so basically you log into your website through OAuth or basic authentication, you enter into a website. then that first page come, that is called the like index.html. So it is returned on that page. Whatever you do, suppose you click a button and all, so basically for all those interaction there are APIs, or nowadays generally REST is very popular kind of API. So there are multiple types of APIs. One is REST, one is SOAP, and there are others also. So these are like set of rules how you write an API. And then API talks to database, and it gets you the data back, and it is shown on your client application. So here client application is nothing but your browser. So your browser gets the related file, it parse them, means process them, and show you the results. So first we will be like, we already know that in websites there is one HTML, CSS, and JavaScript you might have heard. So HTML is hypertext markup language. So hypertext means, it's actually previously what was the case, that initially the websites were not capable of doing audio video processing on website side and all. Like YouTube was not possible with the initial set of website. So that kind of thing was not there. So at that time the HTML was used just for transferring, this HTTP was used for transferring text. And this was like markup, like how you mark where is the head starts, where is the head stops. So like we will be discussing the tags here. So basically this is a structure of a basic HTML document. So you have a document, then you have HTML, then you have head, body. So basically head contains the metadata, like the title of your website, and other things also, like a link to a CSS script. In body you have the whole content basically. So we will be discussing the main tags. One is heading. So in heading you can have like h1 to h6. In paragraphs, that is basically for normal text. So you can have a paragraph, you can write text there, and there are many more. We will be looking into that, like anchor text, link text. Anchor text are also called link text, and images and divs, and many more. So like in basically as we are discussing URL also. So suppose you need to go to other page, then one is very important tag, that is anchor tag. So you put anchor tag is something like this. So it has closing, opening A, then a closing A tag, and then inside you give a href. Href is nothing but the actual link, HTTP or HTTPS link, where you will go from this. And this is what shown on button or the text where you will click me. So this link is not shown actually. Something whatever you write here is shown in the part of click me, and then it will take you the website. We will be discussing with this in all hands on session. And now there is a URL. So URL is your resource locator basically. So as you might have seen in websites, suppose http colon slash slash google.com, or you have seen http colon slash 127.0.0.1, port is suppose 8000 of wherever you are hosting your website, and then you give the full path, like user slash Rohit, or you give like images slash tech talk. So those things comes under the document name and parameters. So this is like protocol for deciding how a resource on your computer will have that full path kind of thing. So basically this is a full path where you are trying to connect through some other application or from some other host or machine. So and then this whole thing is kind of enabled by, so this whole website communication is enabled by hypertext transfer protocol. So as we discussed, like previously it was only text, but nowadays we can transfer multimedia, audio, video, images. So I think now it should not be hypertext only, you can say hyper multimedia or hyper video also. Anything is possible now, but as the conventional name is going on, so it is hypertext transfer protocol. So through this protocol what you transfer are HTML, CSS and JavaScript file, basically the front end of your website, and the data is processed on the back end. So we would discuss some history of this World Wide Web. So I do not think there will be anybody who does not know www. They never might have heard of www. So this was the first website, I think. Info.sun hypertext. This was the one initial website that was developed by CERN, and there I would show you the website. I will stop the screen share for once, and then I will share the whole screen. So just give me a moment. Can you see my screen? Full screen?
Yes, sir.
Okay, thank you. So this is the first website that you can see. So as you can see, this is nothing like what we see today is like YouTube, Facebook, Google. This was very basic website, and what Sun was planning to do basically, what the story behind is that they had suppose set of documents and they wanted to share internally. So this was developed. So that's why text transfer, hypertext transfer. So this basically are just paragraphs. This is heading, this is paragraph, and these, as you see when you hover over them, you see in the bottom left side that they are pointing to some link. When you open that link, you will be going to the other document. So like you can travel from one document to next document. So this was a very simple website compared to now, but very useful one. So that's how the World Wide Web came into play. And apart from this World Wide Web, basically when you see like www and this .com part, so these are actually folder structures. So have you only seen www, or have you seen other initials also? So I think if you might have noticed, there are like drive.google.com. So com and .in, you already understand. I think these are like commercial and India specific websites. These are domains, and the initial part is the kind of service it is. So if it is a web application basically, then www you have, and most popular 95% I guess are www. But there will be drive.google also, there will be app. Your website also. So that are also possible. So it's not just limited to World Wide Web only. You have other initials also there. So one interesting thing that I would like to show here, the capabilities of your browser that we would like to discuss, is suppose you have this web page, and if you want to clone this, you can do it. So suppose in every browser there is one option for inspect. So if you inspect this, basically you, as you see here, the whole content of this website is shown. So as you can see, we discussed some HTML. So this is some basic HTML here. This is HTML tag, and you can select any element and see what is that. So this is HTML. This is head. Head will have some metadata. In this case, you have this body, and there you have this paragraph content. And as we selected this is basically an anchor link. This is called anchor link. So this has summary.html, and the summary.html is basically pointing to http info.sun, the full website. So through this inspect tool, you can copy the HTML of any page from here, because this is your browser is your client basically. So it got all the files here, and then you can have the CSS and JavaScript of that also, and you can try developing through this. So basically, this is a very useful tool. You can write JavaScript also here. You can see like how the look and feel of that website is, this margin, border, everything. So this is like styles is CSS part. So this one good application of your browser. Okay, so we will be going back to the our slides. So this was the first website that was developed by Tim Berners-Lee, and the attempt was to share the documents. So that's how this hypertext came. Okay, so one second. So in this HTTP, there are two things basically. One is you when you enter a URL or basically a website full path into your browser, you send a request. That request is called GET request to a server. Server can be a separate machine where that suppose google.com is hosted. So you send a request, get request, it receives that get request, and it sends you information back, and that HTML, CSS and JavaScript file consolidated together by your browser is shown to you. And in this request response model, there are other methods also. In request, there are other type of request. Basically, it can be a head request also. In head request, you get the metadata of the that URL. You do not get the documents, like you do not get the page, but you get the metadata of your URL. In post is something like write, get is something like read, post is something like write. So suppose you want to change your password, so that kind of request where you want to change something are sent through post. One advantage of this is that suppose if you send your password through a get request, everything is visible in the URL portion of it in parameters. If you send through post request, it will be hidden. So it will suppose go into an envelope kind of thing that only can be opened on the server side. It cannot be opened in middle. It will be shown blank dot 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 kind of. And put is also uh, put is also a like a right thing, but it's basically more like append or replace. So post and put do somewhat similar purpose, but post is may you can have a totally new entry, and put is somewhat like replace the data, overwrites the previous data. So we already shown you in the inspect part, like through Google Chrome inspect tool, that there are like these three elements like HTML, CSS and JavaScript. And one more thing is XML and JSON. So XML is also a markup language, and JSON is like JavaScript object notation. So these are not directly used for sending website. These are used to send a data basically. So suppose you have an SQL table, or you might have heard about databases. So there are SQL tables or no SQL also. So you have some data, some ID, some name. So it will be formatted into XML, JSON, or there are other formats also like CSV also. But in website terms, we have like XML and JSON mostly. So this data will be formatted into XML or JSON and will be sent to you. So the browser will be able to understand like IDs 1000. This is called like dictionary model basically. This is kind of a JavaScript object that is basically like a Python dictionary. This is key, ID is key, and this 1002 is value. So key value pairs are sent, and then this can be processed. So XML and JSON, you can like get an overview that it is used to send the data. So now we will have one very small hands-on exercise to kind of summarize and see how these things work into action. So suppose you have blank. This is a like a very small setup. This website is called codepen.io, and this you can do in your system also, but for the simplicity sake, we linking and all of the CSS and JS, we will skip that. But suppose you have a blank page, and then you just so you see there is no formatting as of now. We only have a HTML page. So we have a H1 heading, and you can have other type of heading also. H6, you will see H1 to H6 are generally the heading. So this will be very small compared to H1, but bigger than this. So you can see the difference. This is paragraph tag, and then this is a basically anchor tag. So if you click this, it will take you to the google.com or whatever is the link you have given. Then these websites are kind of boring basically if you are just giving HTML. So in case you want to make it beautiful, basically look and feel wise, that is what nowadays front end is all about, to make it look good, not only the processing part. So then you can like change colors and all, backgrounds and all, and you can do many more things. But for simplicity's sake, suppose we change the color to red of this heading. Okay, so basically you can change the look and feel of your website. And in JavaScript is basically a kind of language, you can say, like Python or JavaScript. JavaScript is mostly used into web development processing part on the client, this browser side. And some frameworks have been developed on this that also handles the backend sometimes. Those are called Node.js and Express.js. And in backend frameworks you have multiple options, like if you are familiar with Python, then you can have Flask, Django, all these things. So suppose some very basic JavaScript, if you write is alert hello there. Okay, so when you say alert, this is basically, it gives you this uh, a kind of prompt. This message come, you can close this by this. And one interesting thing is that these are very basic things, but very tricky sometimes. In many websites you might have seen that this message does not go away. You cannot even close it, then you have to crash the browser to get out of it. So these are like very basic JavaScript things. You make a loop of this alert, and then so basic kind of attacks also. So you need to take care of these things into security. uh, but this is very basic JavaScript. And JavaScript is something like HTML is your skeleton. Then the CSS gives it colors and width, height, everything. So it the looks. And JavaScript, the processing part, you can do animations through it, you can move the objects. And it is basically dynamic. So suppose if you write a date, that in some part of the website some date should display, then it will fetch the live date. It won't be a static thing. So it will makes your website dynamic. So if you have only HTML and CSS, your website is static. If you have JavaScript, your website is basically dynamic. And like animation and also are there. So this is a very small hands-on kind of demo that I wanted to show you. I'm going back to the our main slides. Okay, so we will be now discussing about APIs, application programming, how that, what some terminologies, because API is the most important part of networking when you say. So if you have networking is basically about talking one host to other. So that is done through API, like front end talks to back end through API. So this is basically the methods are like get, post, put, and delete. So you might have also heard like CRUD, CRUD. So it is like basically get is basically read of that CRUD R, and post is the write part. Put is basically append or replace, you can say. And delete is basically removing the entry. So suppose if you have a user, if you sign up to, so if you just ask user information, that is get. If you want to send password or something, or you want to update password and all, create basically new sign up, that is post. If you want to update that password, that is put basically. And if you want to delete the full user account, that is delete. And this API is basically doing operations on databases generally. So there are basically two more popular, you can say, type of API: SOAP and REST. So this is a very famous debate, like SOAP versus REST. So like in practical basis, I would like to summarize the differences. Is that all these details aside, that XML based things there. SOAP was kind of popular previously. Nowadays, REST is taking the pace up. So previously we used to transfer message transfer was done through XML only. Nowadays JSON is more popular, and WSDL was used. So WSDL was like format, a language format to write services. So your website is basically running a service, and that how do you write that language was called WSDL. And nowadays, as XML and JSON are more easier to write, so they are taking place of this WSDL and all. There are websites also in WSDL and all, but depends on the situation. Then previously you used to invoke them through RPC, remote procedure call. So you might have heard the term XML RPC. That was the like server client model. You have a server, you have a client, you expose a function to that RPC, and the client will try to call that, and XML will be sent. So this was XML RPC. Nowadays you can simply call API services database through this URL path. So like you have HTTP facebook.com, you have /API/v1/username. These kind of paths you can do. Previously it was through the function name of that RPC, and it used to not return human readable. This is the main point. And nowadays what it returns is XML and JSON, so you can also see it how the data is returned. So and but still it is somewhat nowadays used in SMTP and FTP. So FTP is file transfer protocol, so basically you transfer a single file from one computer to other. And SMTP is simple mail transfer protocol that is used for email. So it is not like that SOAP is not used. SOAP is also very popular, but in a web development basis we use REST basically nowadays. And basically REST is easier with JavaScript, and performance is also better. So REST came later and became popular. So REST was, I think, a research project of some PhD student. So he had just written some set of rules that became REST, and those REST API became very popular because of those set of rules. That is somewhat like a very popular PhD project that was there, I guess. So so in REST API, so basically, as REST is more popular, we will discussing REST APIs. You send a request, suppose GET request or POST request. POST request is basically in case of passwords and all. So then it goes to server, and this protocol that is used here is HTTP, and then the data comes back from this is basically a database storage representation. The data comes back, the user info and all, to client, and it can be in JSON or XML format, mostly in JSON nowadays. So to test these APIs, when you develop a website, basically to check the communication, like suppose you have set up a LAN basically, then how you check if your computer can talk to that thing or not? You try to ping it, you try to connect it. Similarly, when you develop APIs, so these are like exposed points. So you test them through Postman. So Postman is kind of tool, and there are other tools also. You can directly use your Chrome browser also, but this is a kind of popular tool that is used. So we will show you some demo kind of thing for this. So suppose there is a some demo website that is called requestresponse.in, reqres.in. Okay. So basically what you see here is the base path is suppose request.in, and then you add this slash users, and there is this get request single user. This is also get request, and there this is post request. When you create something, this is post request, and this is the kind of data that you need to send with that request. Put, patch, delete, these are all the methods of API. So basically suppose this you want a single user data. So we can go to Postman, this website, and then there is setup and all. You can create an account. I already have the account, so I will directly show the request part. So suppose you write the main part of that website, then you write API, whatever this path is given, API slash user slash 2, and you send the request, and then the data comes back. This is JSON format. So you can see this is like key value pair. So you have data, then it has multiple keys here. ID is 2, email is Janet Weaver at request response. So some dummy data, but this is how the data comes back. Then you can process it. So this is a very good website if you are new to APIs and all, to test your APIs, to know about APIs, how to create APIs and all. So this is, I would say, is the building block of networking when it comes to web development, APIs. So if you want advanced things on this, these are the some resources that I would suggest. Okay, so now moving from APIs, now we will be talking about security and domain name services, and how that pinging to a website and all works. So we will start from domain name server or domain name services, DNS. So how the thing is like, how, when you enter a website, how that website is converted back to the IP address, and that, suppose if I say that 182 or something something is the IP of amazon.com, you need to remember it. So it is not
वीडियो में नहीं आ
possible
रहा,
basically.
फोटो के पास किया क्या?
Hello.
इसी में कनेक्ट किया हूँ।
Hello,
Uh,
dear
yeah.
participants, please mute your mic. Okay, sir, please start.
Okay. So basically, when you try to send a request to directly the IP of some website, suppose I say that amazon.com is 72.21.215. This is very difficult to remember, first thing, not practical. If you say you need to remember 100 sites, then you cannot do it, or it's not good also. And second problem is with this direct IP accessing is that these IPs can change. Suppose your server gets restarted, or you change the server location, and now this IP is, suppose instead of 90 it is like 270. Then who would take care of that? So that is called domain name server. So there is a server which keeps updated entries of all the website names to their current IP. So whenever you say amazon.com, it goes to the domain name server. It gives you back the IP of that your website, and then you can connect to that basically website through that IP only. So basically the communication happens through IP, but you need to first convert from, basically need to resolve the name to IP. So that is done through domain name server. So I would like to show you how it is done in Linux. It is somewhat bit different into case of Windows or Mac, but this should give you a basic idea. So we will be discussing where the files where it is mentioned, like the DNS and all, and some basic command that helps you if something is going wrong, if you are not able to connect to suppose google.com. So I will show you that. So first of all, this is like basic Linux interface. There are some very basic commands like ls, pwd, like present working directory, ls is to list and all. So there is cat command also to show the content of this. So etc host file contains the host name of your systems. So suppose this is 127.0.0 local host also. You can ping this through localhost. You can ping this through 127.0.0 also. And there is one file called etc resolve .conf. So here you see this name server. So this name server is basically which is forwarding to your DNS server, and there are some open servers also like Google's domain name server, that is 8.8.8.8 and 8.8.8.4. And this search where you need to search like the tables where you will search uh, for this DNS entries and all. So that is suppose generally set to your whatever is your service provider or Wi-Fi. So basically, so the table of that is set to basically that Wi-Fi or service provider. You can have your own DNS server also, that is also fine. So suppose if you do ping google.com. So first of all, if you suppose need to see the help of any command, you can do man. Man is the manual pages of any command in Linux, and you can see the whole command. So ping is very basic command. You are trying to connect to google.com, and you can see this is pinging back. Okay, so basically the connection is working. Then you have you might have by now no route command. So basically this is saying that these are my router addresses and all, how from where I need connecting to the outside gateway, and from where my data is going to the outside world. And then you have like if config, some commands that shows your IP addresses and all. So basically I'm connected to currently this WLPS1. This is my Wi-Fi, this is my IP. And suppose when I ping this google.com, what is the IP of this google.com? What is the DNS? What DNS returns basically? So you can have ns lookup one command is there, and you can do google.com and it will give you. So the IP, current IP of this google.com is this 127 to 17 166, this one. And suppose if you want to trace the whole like how it is hopping from one machine to other, the request. So you can have trace route, one command is there for google.com. So you can see from like 126.6, so it starts from your machine, then it gets to next your router, then it gets to server DNS and all, and it goes to the outside world. Here you see it changes to 10.10 series, means it is gone out of your local network, and then in the end it reaches to google.com. So these are some useful tools if you want to debug. Suppose if in trace route it is stuck on this 7th point, so maybe link after this is broken, and then this Cisco tools and all come into play for further debugging. So this is basically a very small demo that I had. Now suppose you by now you understand that you can create a website, and you can have that website in your local system, but when you host it on a server, basically some other persons can also use it. Then you need to consider some things. So I would like to discuss that. First is the server's maintenance, means some there will be some maintenance cost also. If you buy one suppose I say like tech talk underscore cil.com, I need to buy this domain name, then I will have to pay for that. And suppose if I scale to instead of like 100 users, tomorrow it becomes very popular and I have 1 million users, then how it would scale? You will need multiple servers that will balance the load. So suppose one server does not heat up or does not crash, if one server is ill, then not healthy, then you will have to spun next server. Those kind of things you need to take care of, and these are generally nowadays taken care by the cloud. We will discuss that how. And there are security considerations. How if somebody would hack it? That is the most important part. We'll discuss that also. So in network security, basically there are three terms. One is SHA, hashing. One is basically keys, public private keys, and symmetric. So symmetric does not have public private, it has single key. Asymmetric has public and private, a pair of keys. And SSL certificates, these are like authentication seals or certificates, you can say, that are given by certificate authority like Norton, Google, big companies, that okay, this website is authentic. So we will first discuss about the hashing. So basically hashing, how it works analogy wise, suppose if you put fruit into a mixer and then it is gives you juice, you cannot get the components or of that juice back. It is very very difficult, if not impossible. Actually it's not that hashing algorithms cannot be break, but nowadays it has become very very secure. So some, for example, suppose example of very basic hash function is module operator. So suppose module is basically remainder. So suppose 15 module 10 is 5, and 25 module 10 is also 5. So if you have the data 5, you cannot say it was 15 or 25, but still you have some guess. So this is very very basic hash function. Suppose a module, and nowadays there are many hash function algorithms like SHA-256, and so basically now it has become very very secure, and there are new algorithms also come into play, but it is possible to break them, but very very difficult. So hash function, if you suppose give a plain text file and you pass it through a hash function, and for this plain text this hash function is kind of a black box, and then you get some gibberish, basically hash text. You cannot get back this from this. So this is, suppose if you are concerned like how Facebook or Google store your password, in databases they will see something like this. So if you are like a Google admin, you will see something like this. You cannot get password from that of your user. So that is how the privacy of users are maintained. Okay. So suppose you have your username, password and all. I have hashed them, the password I have hashed, and it is into this. So this is first step of security. But how would you hash it? Like there will be one communication, like what is used and all, metadata part. So we will be looking into public and private key. So for example, I have my laptop is client and you have google.com server, and there is symmetric as we discussed, there is symmetric and asymmetric key. So symmetric key is, suppose I say this is my key and I send it over the Wi-Fi, and somebody man in the middle, basically a hacker, is listening or snooping in between. It will make a copy of it, and when the server sends me back the data, it can see what it has sent. It can steal my password. So the better way of doing this security is public and private key. So basically public and private keys, you can take an analogy that these are both not keys. One is key and other is lock, or vice versa. If other is lock, if other is key, then this one is lock. This is like that. These both are generally not treated as keys. One is, so suppose I send data. First I send my public key, and private key I always keep with me. So first we generate the key pair. So these are like part of a puzzle. So you give half part to someone else and keep the other half always in your local system. You do not send it, and with that half part, the public key, you can share it to anybody, and somebody can just lock the data. So you are giving like a box. So the server will keep your things, like whatever data it want to send in that box. It will lock it, and suppose if the hacker, the man in the middle, sees that box, it does not have your private key. It has that other half, that public key, but it does not have private key, so it cannot open it. So that box comes to you, and you have the both half. You can mix them. There are multiple technology. You can mix both halves, or you have the private key that only is enough to open that data. So that is how the security is maintained. So this private key is never shared. This is how SSH and this public private key works generally. Then there is two very popular term, HTTP and HTTPS. So HTTP is basically, we already know, basic normal transfer protocol. HTTPS is basically the secure HTTP. So this is basically encrypted. And how it is encrypted? The first thing is, suppose uh, somebody clone a Facebook page, and the page looks just like that. It is like http facebook.com. So basically it has get hold of your laptop or your Wi-Fi settings and all, and when you resolve the facebook.com, it goes to your the hackers google.com or facebook.com. Then you will be giving him the private key, sorry, the public key, and he will be giving you the data, so he can manipulate you. So how you will ensure that hashing is fine, key is fine? How will you ensure that the website is not fake? So basically server, this certificate authority ensure, gives you certificates. So like your browser, this Google Chrome and Firefox, they have the original copy of a website certificate. So they know how the certificate of facebook.com actually looks like. So they, whenever you ask a server, so your browser asks for them, show me your certificate, and this if cannot be forged easily, you will have to make this sign into from some certificate authority like Norton and all. So if a hacker sends them a forged certificate, your browser matches it with the original certificate, and it knows, okay, fine, this is not facebook.com, this is some imposter, and it denies the connection. That is how HTTPS is secure. So suppose if hacker, you do not have HTTPS, you think that facebook.com, this hacker is facebook.com, and you send the password to him, he will happily take your password, and then your Facebook is hacked. It is like that. So you need to always ensure that any website that you visit has HTTPS, the secure written there. So whenever you send password and all, it will first ask server for certificate and verify. If it is not valid, then it will not send the data. This is how it is secure. So mixing the DNS and HTTP part, the overall flow is this. You send a request, then say facebook.com or website.com, this is the IP is like resolved through DNS. Then you go to you ask for the SSL certificates, the handshake happen, the SSL handshake, and so if that website is trusted, then you send that website your public key. Otherwise you do not even send them their public your public key. And then your normal API is, and this get and post kind of things start. So that is basically website security in short. So you can read more about it. It's a very interesting topic. Okay, so this was basically a basic overview of network security and network how in web application. So I would just want to tell you some tools that are there. uh, Basically, if you are prototyping a new idea, this is, I think, sometimes this happens that if you are good into academics like research and all, but you are not very familiar with the technology side, and you struggle sometimes for like 15 days, 20 days just to know the basics. So I would just suggest some tools to you where you can start like rapid prototyping, you can say. Like Linux is the operating system, the choice of developers nowadays, I would say. And then there is Python. So in Python is a very popular language, so instead of C++, Python is comparatively easier to learn. And there is Jupyter notebook, so I will show you just like how a Jupyter notebook looks. So this is a basically Jupyter notebook. So you can process this data and results and all, and you can make PDF out of this. So suppose you want to learn a new language, so the basic thing that you should learn is taking input output first. For any language, if you are learning suppose Scala, you might have not even heard of Scala before, but whenever you go from one language to other, you will do these things. So basically you will learn input output, then you will learn the if else conditions, then you will learn looping, then there comes the modules and libraries. So suppose these libraries are like pre-written code from someone else. So suppose I take this matplotlib, and we then from this using Python only, I can show a XY plot. Then, and this whole thing from a researcher's perspective, I can make a PDF out of it from this Jupyter notebook, and use it to share in my mail and all, my research paper and all. So Jupyter notebook is very good tool. Apart from that, you might have heard Git. Git is basically version control. So suppose you do incremental changes. Today you just made the first page of that, then you fixed some bug into that. So Git is also like that. So like for Linux, these are some basic commands that we have already shown. Okay, so all these commands we have already shown. Then in Git, there is this basic like initialize a Git. So these are some important topics that I'm just telling you the names so that you can look into if you are new to prototyping and all. You need to prototype something. So you should look into Git. And then GitHub is the server side of that. GitHub is something that have website, you can store data there, you can store some open source project there. So this is the initial point: git init, git add, some make a commit, make a clone, make a branch. So some terminology just I'm introducing you. And see, this is one example that you have beautiful graphs through Jupyter Notebook. Then this term sometimes confuses people, DevOps. So basically DevOps is development plus operation. Operations is basically deploying a website. So you build a website through Git, you do incremental changes every time it will be built, and it will go into staging, then it will go into production, and production is the website which is shown to the actual final customer. So this whole cycle is called DevOps. There are some tools like Docker, Kubernetes. uh, so this is, and nowadays this deployment part is generally done on the cloud. So for cloud, this cloud is basically nothing. If you are hosting a website, suppose in your laptop you have 2 GB RAM and some basic configuration, and suppose 1 million user tries to connect to your website, then your laptop will be fried. Basically it will overheat and all. So cloud, what is that? They have very high end machine, and they do load balancing also, sharing also, and they just charge you for rent. So cloud is nothing but actual machines stored somewhere by Google or Amazon in their server farms. Okay, so these are the three main players in this domain, and this is some, like you can say, a page that I have one account. So this is a page from that. So this is how a Google Cloud looks like. So this is something that comes up when you already have a small website, you already know how to deploy it in your local host like 127, and then you want to make it open to all community or open to all as a commercial one. Then this cloud, so they charge basically. So so I think here I would end. So these some topics that I suggested is because in case you want to prototype, these are some starting points. You can start looking into it. And Google Cloud or any cloud like AWS and all gives you some free initial credit. So this is paid generally, but initially you have some 22,000 rupees initial credit that you can easily use for 1 or 2 3 months. So this is all from my side. Uh, Thank you. Hope you enjoyed the session.
Thank you, Rohit sir. I would request all the participants if there is any question regarding the session, so feel free to ask. I think there is no question from participant side, sir. Thank you very much for your wonderful session.
So I will give back the control to you for
Okay,
further proceedings. Okay, thank you
okay,
all.
sir.
Okay, Shivangi. So can we start with our valedictory session?
Okay, sir, we will start.
Let me check whether all guests have arrived.
Okay, sir. Please let me know.
I would request all guests to kindly turn on their video.
मेरे को स्ट्रक्चर ना
Hello, Priyank sir.
Just wait for a moment.
Sir, actually, Rohit sir presentation is still visible on the screen.
For me, it's not visible now.
Yeah, but I think it's visible for participants because I can see it.
I don't think participants can.
I'm not getting. Priyank.
Yes, sir. Is it visible, sir?
No presentation is visible.
Okay, yeah, it's not visible. Okay.
Yes. Only Purushottam sir has not arrived yet. Let me check it.
I think it is visible for few participants. They are just telling in the.
प्रियांक हाँ नमस्कार वो शेयर करना है यस एक काम करो इसमें जो है ना ये वाला एक्सेलेंट ये पूरा है ना, इधर ठीक है
Okay, Shivangi. So now I think we can start with our this valedictory session.
Okay, sir, I'll start. Never stop learning because life never stops teaching. With this beautiful quote, I would like to start our valedictory session for 3-day online interactive refresher course on computer communication technology, organized by Electronics and Telecommunication Department, WCL, Chandrapur area. Today we have with us Honorable Chief Guest Shri A.C. Singh Sir, General Manager, Chandrapur area, Guest of Honor Shri M.C.S. Rao Sir, General Manager E&T, CCL, Shri N. Purushottam Sir, General Manager E&T, WCL area. We also have with us GM Operations Sir, WCL Chandrapur area, Shri B. Ramarao Sir, and Staff Officer of WCL Chandrapur area. On behalf of Electronics and Telecommunication Department, WCL Chandrapur area, I offer a gracious welcome to all. Now I take a pleasure to invite convener of this program, Shri Priyank Mishra Sir, Area ENT Officer, WCL Chandrapur area, to give opening address to this valedictory session. So please. Priyank sir, are you there?
Audible, Shivangi? Am I audible?
Yeah, you are audible, but your video is not there, sir.
Okay. There is some network problem perhaps.
And AGM sir video is also not visible.
Okay. Am I audible now?
Yes, sir, you are audible.
Now?
Sir, you are audible, but your video, yeah, you are audible, but your video is not there. I request you all to please stay connected. There is some technical issue. We will start with the session shortly.
Am I audible?
Yes, sir, you are audible.
But my video is not available, right?
Yes, sir.
Okay. Okay, anyway, if it is not available, I will continue. No issues. Okay.
Okay, sir. So please start with your. Yes, sir.
Yes,
Your
now,
video is available.
yes, now it's available. Okay.
Yes, sir.
Okay. So, respected chief guests of this program, Area General Manager, WCL Chandrapur area, guest of honor, MCS Rao sir, General Manager ENT, CCL, and Purushottam sir, General Manager ENT, WCL, General Manager Operation, and the staff officers of WCL Chandrapur area, invited speakers, and dear participants. I said in the inaugural session of this program that we have entered in fourth industrial revolution era, where the line of separation in physical and digital world is getting blurred. The successful conduction of this program bears a testimony to this new normal. Who would have thought that we would be conducting such kind of online programs a little back ago? But now this is a new reality. I am happy that all of us has realized the potential of technology in conducting such online programs through which the learning and teaching area has been revolutionized. Thankful to Area General Manager WCL Chandrapur area for giving us this opportunity and all support for conduction of this program. I am also thankful to GMENT, WCL and GMENT, CCL, General Manager Operation, WCL Chandrapur area for all their support and guidance. I am happy to share that we saw a good attendance of participants and they remained actively engaged in all sessions. What has been very particular about this program is that we not only covered theoretical aspects, but there were some hands-on sessions as well. We conducted online labs in which faculty demonstrated the ideas which were discussed in their theoretical sessions. I am thankful to all faculty members who volunteered in this program and conducted wonderful and memorable sessions. With these words, I would like to conclude. Thank you. Over to you, Shivangi.
Thank you, sir, for your speech. Okay, now moving forward, I would like to invite one of our participants, Mr. Shivaram from Hyderabad, who has attended all our session of this program. Shivaram sir is scientist E with the Indian Space Research Organization ISRO. So I would like to invite sir, please.
Yeah, thank you, ma'am. Am I audible?
Yes, sir. Sir, you are
Am I
audible.
ma'am? Yeah. Good afternoon to all. On brief account, speaking about this program, I feel this program was not only useful and informative for people working in communication sector, but also it had given a sufficient insight for all those who are from different fields. I also thank and congratulate the entire organizing team and also the support provided by the management for successfully carrying out this program. And I hope to see such programs being conducted in future. Thank you. Thank you.
Thank you, sir. Thank you for your beautiful feedback.
Yes.
We have one more participant with us, Miss Manisha Bharadwaj from Roorkee. Madam obtained PhD from IIT Roorkee. So, madam, please.
A very good afternoon to all. Is my audio and video both visible?
No, ma'am, your video is not visible to us.
Okay, let me. Okay,
Yes,
is it
ma'am.
visible now?
You are not. Yeah. Yes, ma'am. You are visible.
Okay. Thank you so much. First of all, a very good afternoon to all participants, organizers, and esteemed speakers. I would like to congratulate and applaud Mr. Priyank Mishra to organize the course on computer communication and technology, organized by the Electronic and Communication Department, WCL Chandrapur area. I think it's a great opportunity taken up by Coal India during this lockdown to organize the webinars and to stay connected. The course was conducted excellently, taking into account both the theoretical as well as the practical implications. As there are very large number of audience, I would also appreciate Ms. Shivangi Sharma for handling such a large audience and keeping the flow of different sessions in the queue. I'm sure the course would have benefit the audience as they are from very different expertise, and I think audience would also have thought of some research ideas. Either they are from industry or from academics or from PSUs. I'm hoping like there is another webinars and seminars also, because during such a lockdown and such a critical time, it's an opportunity that we share the knowledge and stay connected. Thank you so much. Shivangi, it's up to you now.
Thank you, ma'am, for your appreciation and feedback.
Yeah, thank you.
Moving
Welcome.
forward, we have one more participant with us, Sri Ramkumar sir. Sir is an electrical engineer and currently chief manager heading system department at WCL Chandrapur area. Sir, please. Sir, your
Hello, am I
audio
audible?
is not there. Yeah, sir, you
Am
are
I
audible.
audible? Okay.
Yes, sir.
Just a second. Uh, respected AGM sir, AC Singh Saab, GM Operation Ramarao Saab, GM ENT WCL Mr. Purushottam Saab, GM ENT CCL Mr. MCS Rao Saab, the faculty Yogesh Sharma from DRDO, Mr. KRK Reddy Saab, Chief Manager ENT from WCL Headquarters, our own Priyank Mishra, Rohit Raj Mishra, the senior engineer from Monta Vista, and also the moderator Shivangi Sharma, and as well as the participants. Very good afternoon. First of all, I would like to thank all of this faculty as well as the organizers, and especially AGM Chandrapur for enabling this program at our level and at WCL at this area. I also thank and congratulate ENT department, especially Priyank Mishra, for visualizing this thing and organizing this program. You may know that this program or the topic of this program is so vast that it is basically a 6 months a semester course, you can say. This has been compressed into 3 days, and I would like to once again congratulate all the participants for patiently hearing through this, and also the faculty for imparting as much as possible within these 3 days. And after attending this 3-day program, I found that especially for working people like us, it would be better if the forthcoming programs could be broken down into half an hour to 1 hour sessions, so that we can do our daily jobs as well as attend this program for gaining information. Now, as we know that we are in implementing ERP systems in WCL as well as other subsidiaries of Coal India, communication technology is the most important and vital link now. And it is imperative that as many people as possible know about the fundamentals of this. And I would like to thank Mr. KRK Reddy Sahab once again for taking the effort yesterday for a long session of almost 4 hours, trying to impart the knowledge about networking technologies and the difficulties which arise thereof. Thank you once again. And I would like to thank especially Shivangi Sharma for moderating this particular program very beautifully. Thank you.
Thank you so much, sir, for your appreciation and feedback. Now I invite our guest of honor, Shri MCS Rao sir, General Manager ENT CCL, to say few words about this program. Sir, please.
Good afternoon, AC Singh Saab, Purushottam Saab, Priyank, Ram Kumar Saab, Ramarao Saab, and all other staff officers and participants. Priyank has given inspiration to entire Coal India that such programs can be arranged by all subsidiaries. I thank you, AGM sir, also for extending all support to Priyank and the entire team of ENT department of Chandrapur area. I am also asking people to organize such program at CCL. Hope the participants have good experience and learned something new about computer networks and communications. Any uncovered topic may please be shared to me on my mail or to Mr. Priyank Mishra so that he can forward to me. So and I can able to cover those topics in my proposed program at CCL. I thank you very much for giving an opportunity to talk on this validation session and wish all success to participants. Thank you.
Thank you, sir. Moving forward, we are delighted to have our distinguished chief guest, Area General Manager, WCL Chandrapur Area, Shri AC Singh, sir. I would like to invite you to address the gathering, sir. Sir, please. Priyank, sir.
Yes, wait, madam. I think there is some problem. Let me check it
Yeah,
out.
yeah, sir. Okay, sir. Okay.
आ गया नितिन okay madam can we announce once again
Yes, sir. Yes, sir.
yes because there was some network problem there.
Okay, sir. We are delighted to have our distinguished chief guest, Area General Manager, WCL Chandrapur Area, Shri A.C. Singh, sir. I would like to invite sir to address the gathering. Sir, please.
Shivangi, we need to interrupt. Perhaps we need to interrupt. There is no voice.
Yes, sir. We'll wait, sir. No problem.
Yes.
I request all the participants, please be connected as we are going through some technical issue. We will start our program shortly.
Okay. Okay, क्या?
ठीक है
Shivangi, we can start once again.
Okay, sir. We are delighted to have our distinguished chief guest, Area General Manager, WCL Chandrapur Area, Shri A.C. Singh, sir. I would like to invite sir to address the gathering. Sir, please.
Good afternoon to all my colleagues. General Manager ENT Western Coast Limited, Sri N. Purushottam. General Manager ENT Central Coalfield Limited, Sri M.C.S. Rao. All the invitees, speakers and the participants. It is indeed a great joy and honor for me to present my thoughts in the valedictory section of this 3 days online refresher course on computer communication technology. First, I would like to congratulate all the people associated with the session, convener, faculty members, moderators, and most important, the participants who showed their interest in the program for its successful completion. When the convener of this program, Sri Priyank Misra, reached to me few days back with the idea of conducting such an online program, I was happy and excited, but also confused as till now we have not conducted such type of program, but I liked the idea and gave my approval for the same to Priyank Misra. Now there is no confusion and doubt, and rather I am very happy, and indeed now I am very much convinced that such program can be conducted with case. In today's world, young people need to know how to generate new knowledge in order to meet the demands of the modern day workforce, to practice professionally at and beyond the level of set standards. The online learning program makes it not only easy but also interesting medium to gain knowledge. During the last 3 days, I understand you had a very good refresher course and participants all over enjoyed the program. I have been told that all the session of the programs, participants actively remained engaged, and that is really a very encouraging sign. This program has got several facets. This is first of its kind program organized by an area in Western Coalfield Limited. Second, we used online platform very smoothly in conduction of this program. There has not been any slightest technical glitch. All sessions are conducted smoothly. Further, the recording of the program has been uploaded on YouTube for wider access to the outside people. This is really a very good thing. I hope Electronics and Telecommunication Department will keep taking such interesting and innovative initiative in future as well. I once again congratulate Sri N. Purushottam, General Manager ENT WCL, General Manager ENT Central Coalfield Limited, MCS Rao, by their concerted effort. And at the last, I just convey my thanks to Priyank Misra, who has made this program a grand success. Thank you very much.
Thank you, sir. Thank you for your warm words of encouragement. They means a lot. Now I would like to invite Shivangi Sharma for vote of thanks.
Okay, sir. Moving forward with the vote of thanks. The best and beautiful things in the world cannot be seen or even touched. They must be felt by heart. Thank you is one such prayer among them. I consider it a great privilege to propose a vote of thanks to all the dignitaries who have witnessed it as a memorable and successful event. Today, my words are not enough to express the gratitude. On behalf of Electronics and Telecommunication Department, Chandrapur area, I would like to thank our Honorable Chief Guest Shri A.C. Singh sir, who provided all support and guidance for smooth conduction of this program. I would like to thank our beloved guest of honor Shri M.C.S. Rao sir, General Manager ENTCCL, and Shri N. Purushottam sir, General Manager WCL area, for all words of wisdom that radiated a source of energy within us. We will ever remain grateful to you, and we thank you for being with us today. Heartfelt thanks goes out to all our faculty, Shri K.R.K. Reddy sir, Shri Yogesh Sharma sir, and Shri Rohit Raj sir, who volunteer for this program and conducted such memorable and wonderful session. We feel proud and thank you for making us feel happy with your presence to this function, sir. I also thank convener of this program, Priyank Mishra sir, who has been instrumental in conduction of this program. An event of this dimension cannot happen overnight. The wheels start rolling months in advance. We have been fortunate enough to be backed by a team of very motivated and dedicated volunteers. I cannot thank everyone enough for the involvement they have shown and the willingness they have expressed to take on the completion of tasks beyond their comfort zones. But last but not the least, I thank all the participants for showing their interest in the program. Once again, thank you very much to all who assembled here. Thank you.
Now, with the permission of Area General Manager, WCL Chandrapur area, the chief guest of this program, we are concluding this program here itself. Thank you. Thank you for joining us.
So sorry.